Hello students, I hope that you all are in good state and whatever you are getting as a materials and as a video, I hope that you have seen the chapters also. We have already covered first two chapters, that is basic concepts of chemistry and atomic structure, and today we'll start classification of elements and periodicity in properties. So that is basically periodic tables. So you have already studied about in class 10, you have know about this periodic table chapters, you have know about the periodic properties and the relationship between with electronic configuration with the periodicity. So we'll recapitulate whatever we have studied in class 10 and we'll know about much more in these chapters in class 11, because you have seen that last time in atomic structures you have to study about different electronic configurations with SPDF configurations. So that will be totally different from whatever you have studied in class 10. That belongs K element shells. So more complicated electronic configuration you have to study. So there will be more complicated relationship with the periodic properties. Now we have to, before starting this chapter, we have to know about the two terms, that is periodicity and another term is classifications. Now the method of grouping of elements into different classes is known as periodic classification of elements. Now what is the meaning of what the periodicity? Periodicity implies repetition after a certain period or gap. In case of elements, periodicity means that it's repetition of properties of elements, that will be the physical and chemical properties of elements after certain gap of atomic numbers. Now the elements with similar characteristics are grouped together and this is known as the classification of elements. Now সাপোজ আমরা তোমাদের স্কুলে ধরো রেজাল্টের ভিত্তিতে ক্যাটাগরি করি, যখন তোমাদের 10th বোর্ডের রেজাল্ট বেরোবে ক্যাটাগরি হয়। সিম্পল, যারা 90% অ্যাবাভ মার্কস পাচ্ছে তাদের একটা ক্যাটাগরি, যারা 70% অ্যাবাভ মার্কস পাচ্ছে তাদের একটা গ্রেডেশন। তো গ্রেডেশন যে সিস্টেমটা হচ্ছে সেটা ডিপেন্ডস অন দ্য ক্যাটাগরি। Similar properties, not exactly similar properties, but similar results. We are taking at similar results. So in this cases also, in this elements also, we are taking the similar properties together. So group will be with similar properties. Now it is not that all the elements are known from the ancient times, because from ancient times we know about the little know about the elements, maybe 2-3 elements or 4 elements, but more and more discovery of elements, more and more elements we know. So there is a need of classifications. Now, why do we need this to classify the elements? We know that now that the elements are basic units of all types of matter. In 1800, only 31 elements were known. So it is not difficult to know all these elements during that period. By 1865, the number of identified elements had more than doubled to 63. So more and more years will go, has gone actually. So number of elements are doubled. At present, 114. Still, we can say that total 118 elements are known right now. So often the recently discovered elements are man-made. Total around 90 to 95 elements are natural elements, and after that all the elements are man-made elements. Efforts to synthesize new elements are continuing. With such a large number of elements, it is very difficult to study individually the chemistry of all these elements and their innumerable compounds individually. So it is very difficult to know all these elements individually. We cannot remember all the elements' name. We cannot remember the atomic weight, atomic numbers, any physical properties, any chemical properties, any compound formation. It is very, because total number of elements are 118. And if we have to identify the elements individually, if we have to identify the properties of the elements individually, it is very difficult to study all these elements individually. So it is need to classify the elements. To ease out this problem, scientists search for a systematic way to organize their knowledge by classifying the elements. Not only that, it would rationalize known chemical facts about the elements, but even predict new ones for undertaking further study. Suppose if there is a gap is present in periodic table, but you can say that maybe the elements are not present, maybe the elements is not discovered right now, but we can say that the property will be like that, the atomic weight will be like that, atomic number will be like that, because you can predict. Why you can predict? Because we actually systematize the group, so you can easily understand the group's behavior. Common behavior is like this, so behavior will be changed like that, so it will be easy to predict the new element which is not discovered right now. Now our first topic is genesis of periodic classifications. So ever since John Dalton gave the atomic theory, scientists were busy to know more details about the elements, their physical, chemical properties, all the properties, their behavior of oxides, hydrides, nitrides, everything. Although the Lavoisier classified the elements into metals and non-metals, he only classified the elements into metals. These are the metals and these are the non-metals. But this is not proper way to classify the elements. Now, some noteworthy atoms in the fields are briefly discussed right now. We'll first study about the Dobereiner's triad. In 18th century, actually John Dobereiner, 1877, German chemist, who actually first arranged certain elements with similar properties in a group of three elements, and which is known as triads. Because three elements are there, that's why it is known as triads. Uh, they were classified, arranged in order of increasing atomic masses, and the atomic mass of the middle element was almost the average or mean of the atomic masses of the first and third elements. But we have observed that the properties, the physical and chemical properties of the triads are similar. For example, if we take elements lithium, sodium, potassium, you'll observe that the sodium atomic mass is 23, lithium 7, potassium 39. If you add the atomic mass of lithium and potassium, that will be around 46. The total value will be the 46. If you divide by 2, average, you take the average, 46 divided by 2, the value will be exactly 23. That is the atomic mass of sodium. Now, if you observe the properties of lithium, sodium, potassium, there are similar properties, like all these elements are metals. All of them show valency of 1. Okay, and all of them reacts with water to form hydroxides. Similarly, calcium, strontium, barium, the atomic mass of calcium plus barium, so add it total, you will get the value 177 total value is, and if you just take the average, it will be 87.5. So I mean total 88.5, and strontium value is 88. So it's nearly equal to the average value of strontium. So you'll observe that the properties are similar. They are metals, and they are having a valency 2, and they also shows characteristics flames, different kind of color flames actually in the flame actually. And third point is chlorine, bromine, iodine. The average value bromine, you will observe chlorine plus iodine. The value will be 127 by 35.5. The value is around 120, 132 and 162. 162.5. It will be near the atomic mass of bromine 80, and the properties are similar, like they are all non-metals, and their valence is -1, and they always form halogen acids. All they form are halogen acids. So he actually, I mean, relate these three triad elements with their physical and chemical properties by this atomic mass. If you just take the average of this atomic mass of the first and third elements, we'll get the atomic mass of the second elements. Now, what was the limitation of this Dobereiner's triad? Actually, he can actually, using these triads, he can actually, very few elements he can observe. These properties can be observed for very few elements, but he could not arrange all the elements known at the time. So it is not a proper way to use this Dobereiner's triad for all the elements. That was the limitations. After Dobereiner, the next major contribution is by John Newland, who was the English scientist. In 1866, he arranged about 56 elements known at that time in order of their increasing atomic masses. So basically, surprised to say that if the elements were arranged in increasing order of their atomic weights, the properties of the every 8 elements were similar to those of first one. So Newland call it a law of octaves. Now, during that time, noble gas family was not known. That is helium, neon, argon. This family was not discovered at that time. So after the seventh elements, he had taken the alkali metals. Let's come back to the first one elements. So after seventh elements, it actually repeats the periodic properties. Some of you must have interest in music. You must be familiar with common musical notes sa, re, ga, ma, pa, tha, ni. After 7 notes, it again comes the sa. Last note is the sa. So it is the 8th note is again coming again the same note. It is repeated again. Similarly, the properties also similar like that. So that's why this is known as Newland's law of octaves. Octaves name is coming from this musical note. If you don't take the consideration with the noble gases, then sodium is the 8th element after lithium, and potassium is also the 8th element after sodium. So basically lithium, sodium, potassium, these are the repeated and they are in the same group according to this Newland's law of octaves. But this law of octaves seemed to be true only for elements up to calcium. After the calcium, this law cannot be applied. He applied this law up to 56 elements, but this law is not cannot be applied after that properly. So whatever he has uh, shown in the elements after 20, that means up to calcium, after that it will be his limitation. Now, for example, cobalt and nickel are placed below chlorine. The halogen groups are there. Below chlorine, cobalt and nickel were placed. But the properties of the cobalt and nickel are not same. They are different properties. So that's why it is not a proper way to group in this halogen group with this cobalt and nickel. And Newland also did not show the noble gas actually. So inclusion of this noble gases disturb this entire arrangement. So that's why this is a limitation of this Newland's law of octaves. This is the representation of Newland's law of octaves up to atomic number 40. This table is given up to atomic number 20 calcium, because after that this Newland's law of octave is not correct. So up to this calcium, this Newland's law of octave is actually correct one. You see that properties of the lithium, sodium, potassium, they are similar. Barium, magnesium, calcium, they are similar. They are put together. Boron, aluminium, they are together. Calcium, carbon, silicon, they are together. Nitrogen, phosphorus together. Oxygen, sulfur together. Fluorine, chlorine together. You have seen this. The modern periodic table also, this will be in a group together. That's why Newland's octave is partially correct up to this point. Russian scientist Mendeleev was the first to make a very significant contribution in the formation of periodic table. So the year of the periodic law was in 1869. Actually, last year, 2019, we actually celebrated 150th year of periodic table, because Mendeleev first shows this periodic table. So he was actually known as father of the periodic table. প্রথম তিনি একটা পিরিয়ড টেবিল প্রপার পিরিয়ড টেবিল তৈরি করেছিলেন, যার ফলে সেটা থেকে আমরা পিরিয়ড টেবিল একটা আইডিয়া আমরা ফার্স্ট পেয়েছিলাম. So that's why we actually celebrated 150th year last year actually, and our school also represented a PowerPoint presentation competition in Jadavpur University last year, and আমরা সেখানে ফার্স্ট এসেছিলাম. Now, what is the Mendeleev's periodic law? Mendeleev's periodic law states that properties of elements, that physical and chemical properties of elements, are periodic function of their atomic weight. Also, what was the features of this Mendeleev's periodic table? Mendeleev's periodic table is based on atomic weight, and it states that the properties of the elements are periodic function of their atomic weight. This table consists of 7 horizontal and 8 vertical columns. Zero group is not included in this table because noble gas was not discovered at that time. Mendeleev arranged around 65 elements in the table. It was clear that there were a number of gaps of missing elements in the table. Mendeleev made several predictions about the properties of some missing elements. He actually predict the properties of the elements which was not discovered at that time when Mendeleev actually make this table. So Mendeleev predicted four elements: Eka boron, Eka aluminium, Eka manganese, and Eka silicons, which is different elements we know about in the later actually. This is actually the representation of Mendeleev's periodic table, where the vertical rows is known as groups, which having the similar characteristics of the elements, and the horizontal rows is known as periods. They are basically seven periods and eight verticals rows are there. See the numbers 1, 2, 3, 4, 5, 6, 7, 8. The zero was not known at the time of Mendeleev's. But later it was discovered that the noble gas is actually there in zero group. This is the first period. This series is the second period. This series is the third period. This will be the fourth period. This is fifth period. This is sixth, and the last one will seventh period, which is incomplete. Now, what is the importance of this Mendeleev's period table? We first actually systematically study the elements. First time arrange a very large number of around 60 elements. We actually arrange these 60 elements into groups and periods. This made the study of the elements quite systematic in the sense of the properties like physical and chemical properties of the elements in particular group. Now, second point is the prediction of new elements and their properties. For example, after this aluminium, gallium is not known at the time of Mendeleev's period table. He actually showed that as a Aka aluminium. He named these elements gallium, Aka aluminium. He actually predict the everything, the properties like every properties, atomic mass, density, melting point. These properties can actually predict correctly. This table shows that the Mendeleev's actually predictions the Aka-aluminium property and the Aka-silicon's properties are given. These are also known as gallium. Later it is found that it's gallium, and the other one is germanium. Now see that atomic weight is given 68 but actually 70. Density is 5.9. Actual density is 5.94. Melting point low is given. Is a low melting point 302.93. Formula of oxide is A2O3, that is Ga2O3. The formula of fluoride is ECl3, that is also GaCl3. Similarly, you say that in case of ecosilicons, it's similar like germanium. So he successfully predicted the undiscovered elements at that time. So that was a quite achievement. Another achievement of Mendeleev's period table was he actually corrected the atomic masses of certain elements with the help of their expected positions and properties. For example, cobalt nickel, he actually placed cobalt before nickel, though the atomic masses of cobalt is more than nickel. But the properties, according to the properties, he actually placed this cobalt before nickel. Now let's talk about the defects of the Mendeleev's period table. Firstly, the position of hydrogen in this period table was not correctly defined. Now, hydrogen can be placed in group 1A along the alkali metals, but it also resembles the properties with halogens groups like 7A in many properties. Like hydrogens can show both +1 valency as well as -1 valency, like halogens and like alkali metals. So thus the position of hydrogen in Mendeleev's period table was controversial. Second point is in certain pair of elements, the increasing order of atomic masses was not obeyed. For example, in case of cobalt and nickel, nickel is placed after cobalt, though the atomic masses of cobalt is more compared to the nickel. So it actually don't follow the increasing order of atomic mass. Exactly. Now you know that the isotopes they having atomic masses are different in case of isotopes. Like in case of hydrogen, tritium, deuterium, these are the isotopes. So isotopes are not given separate places in the period table, but as it is placed according to the increasing atomic mass, so isotope should be placed in a different way. But this is not placed in case of Mendeleev's periodic table. So that was the defect in this table. Next point is some similar elements were separated and dissimilar elements were grouped together. According to Mendeleev, the elements placed in same group must resemble in their properties. But there is no similarity among the elements in two subgroups of particular group A, group B divided this group. There is no relation between that. For example, lithium, sodium, potassium present in group 1A and is quite different from copper, silver and gold which are present in group 1B. So group 1A and group 1B there is no correlation between them. Now, in case of copper and mercury, they resemble in many characteristics, but copper has been placed in group 1B, whereas mercury has been assigned in the position of group 2B. So, though their characteristics are similar, they are placed in a different way. So, these are the fallacy in Mendeleev's periodic table. And last point is the Mendeleev could not explain the cause of periodicity among the elements. What is the main reason behind it? The periodicity of these elements. So this is not actually explained by Mendeleev. Though there are defects in the Mendeleev's periodic table, but we cannot forget this periodic table. There is a huge contributions of Mendeleev's regarding this periodic table. So that's why he was known as the father of the periodic table. And the modern periodic table is based on this Mendeleev's periodic table. Next is modern periodic table. In the year 1913 or around 1914, English physicist Henry Moseley, who actually studied the frequencies of the X-rays, which were emitted when certain metals were bombarded with the high-speed electrons. He found that in all the cases, the square root of frequency can take the square root of the frequency was directly proportional to the atomic number of the atom of the metal. So frequency here, the root of frequency, square root of frequency is directly proportional to the atomic number of metal. So frequency increases according to the square root of the frequency increases according to the increasing of atomic number. So upon investigation, he further stated that there was no correlation between the frequency and the atomic mass. Actually, Moseley plotted the frequency versus atomic number graph. He showed that there is a relation between the frequency and atomic number, not atomic mass. So he actually showed that modern periodic law, which is that the physical and chemical properties of the elements are periodic function of their atomic numbers, not atomic weight. So whatever we have defects we have seen in Mendeleev's periodic table, that was totally, corrected in this modern periodic table. This is the modern representation of the modern periodic table, which you have studied already in class 10 onwards. There's a 7 periods are there, and the total group is 18 groups are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 groups are there and 7 periods are there. Now you say that there are two groups are there, lanthanoids and actinoids, which belong to period number 6 and period number 7. Period number 6 consists of lanthanoids, these elements, and period number 7 consists of actinoids, which are incomplete. You see that in the group 7 is not completed. Let's say the features of this modern period table. Modern period table is also known as long form of period table because it consists of 120 elements around or more stable. Uh, the long form of period table consists of horizontal rows called periods and vertical columns called groups. You have already know about this. There are 7 periods and each period state with a different principal quantum number. So I'll discuss about this here. There are 18 groups in the long form of period table. There are 2 series at the bottom of the period table. These consist of 14 elements after lanthanum and 14 elements which follow actinium. The first row is called lanthanides and the second row is called actinides. Now you will observe that in the first period there are 2 elements are present, hydrogen and helium. In the second period, total number of elements are 8. 1, 2, 3, 4, 5, 6, 7, 8. So 2 elements in S group and 6 elements present in P group. Total 8 elements are present. The third period, total 8 elements are present. In the fourth period, total number of 18 elements are present. And fifth period, total number of elements are present 18. In the sixth period, total number of elements will be 32 because lanthanum, after lanthanum, lanthanoids, this group is belongs. So 12, you have to add 12, I mean 14 elements after this 18 elements. So 18 plus 14, that is equal to 32 elements. So 32 elements are there in period number 6. In period number 7, there should be, it's an incomplete series, incomplete period. The total period should be also 32 because this contain actinoids, 14 actinoid elements. That's why it should be 32 elements, but it is not completed actually. Now, what is the reason behind this number of elements? There is a relation between the electronic configuration with the number of elements. Basically, you have seen that we have learned about in last chapter that S orbital consists of 2 electrons. Similarly, p orbital consists of 6 electrons because three p orbitals are there, px, py, pz. So there are 6 electrons. And in the third d orbitals consist of 5 orbitals, dxy, dyz, dzx, dx square, y square, and dz square. So there are 10 electrons are present in d orbitals. F orbitals, there are 7 orbitals are there, so 14 electrons are present in F orbitals. So we have to apply that number of electrons will be increases. As you see, the atomic number actually implies the number of protons. Atomic number means number of protons. Now, number of protons is always equal to number of electrons in any neutral atom. So whatever the number of protons in the nucleus, that same number of electrons will be there around its nucleus. So it actually implies the number of electrons. So from this electronic configuration, we can easily find out the atomic number of neutral atom. So there is a relation between the number of electrons and the atomic number. Now in the first period, you'll see that only one s, the electronic configuration is one s. Now s orbital consists of 2 electrons, that means 2 protons will be there. So number of elements will be 2. In the second, the configuration is 2s2 2p6. So 2s2 means 2 electrons is there and p6 6 electrons. 2 plus 6 8 electrons are there. 8 electrons means 8 protons. So it will increasing order of protons atomic number. So total number of elements will be 8. In the third, 3s 3p 3s2 3p6 total number of elements will be 8. In the fourth, 4s2 3d10 4p6. Maximum number of electrons will be there. 4s2 3d10 4p6. So 2 plus 10 plus 6. That will be 18 electrons. So 18 electrons implies 18 protons. So atomic number will be increases from 1 to 18. Total will be the 18 elements will be present in third period. The fourth period also, in the fourth period, the fifth period also 5s2 40 10 5p6. So that will be the total 18 elements will be present. Similarly, like fourth period. Now in the sixth period, the outer electron configuration will be 6s2 4f14 5d10 6p6. Maximum number of electrons will be present. So 2 plus 14 plus 10 plus 6. So total number will be 32. You calculate it. That will be the 32. So 32 electrons is present. That implies 32 protons. So atomic number will increases. So 32 elements will be present in the sixth period. Similarly, in seventh period, 7s2 5f14 6d10 7p6. So total number of electrons should be 32. But as it is incomplete, why? Because all the elements were not discovered right now. The 118 elements are discovered till now. So that's why it is incomplete. But the elements will be actually, if the maximum elements will be present, the actual elements will be 32. After that, a new period will be there. If there will be new elements present, then there should be a new period. But it should be maximum 120 elements can be present in period 7. Up to period 7, total number of elements will be 120, not more than that. Next is nomenclature of the elements with atomic number more than 100. Now it is very difficult to know about these elements, 100 elements, more than 100 elements. We cannot name this all the elements. The naming of the new elements had been traditionally the privilege of the discoverer, and the suggested name was ratified by IUPAC naming. In recent years, this has to lead to some controversy. The new elements were because যে 100 এলিমেন্টস যেটা আমরা পেয়েছি তার পরের নামগুলো বেসিক্যালি ডিসকভারের যারা যারা যে ডিসকভার করছে তার নামের ভিত্তিতে নামগুলো দেওয়া হয়েছে। তো সেগুলো অনেকটা ডিফিকাল্ট, মনে রাখাটা খুব ডিফিকাল্ট, কারণ বড় বড় নাম। সেক্ষেত্রে রিসেন্টলি এটা আইউপ্যাক নোমেনক্লেচার অনুযায়ী নেমিং করানো হয়েছে। The new elements with very high atomic numbers are so unstable that only minute quantities, sometimes only a few atoms of them are obtained. Their synthesis and characterizations therefore require highly sophisticated, costly equipment and laboratory. Such work is carried out with competitive spirit only in some laboratories in the world. Scientists before collecting the reliable data on the new elements at times get tempted to claim for its discovery. For example, both American and Soviet scientists claim credit for discovering element number 104. So both are arguing that this is my actual discovery, and the American scientists saying that this is my discovery. So the Americans name it Rutherfordium, whereas Soviets name it Kurchatovium. This is very difficult to pronunciation. To avoid such problems, the IUPAC has made recommendation that until a new element's discovery is proved and its name is officially recognized, a systematic nomenclature be derived directly from the atomic number of the elements using the numerical roots for 0 and numbers 1 to 9. These are shown on the table in the next slide. Now, 0 is given by the name nil, 1 is given by un, 2 is given by bi, 3 is given by tri, 4 is given as quad, 5 is given as pent, 6 hex, 7 sept, 8 oct, and 9 n. So name will be come according to the naming of these digits. Now, the abbreviation, that is a symbol of these elements, will be use the first letter of this naming. So in case of nil, first letter is N, so abbreviation will be N. U will be the, in case of 1, the abbreviation will be U. In case of 2, it will be 3 T, 4 Q, 5 P, 6 X, 7 sept, 8 oct, 9 E. So when 7 S, 8 O, and in case of 9 E. So N U B T Q P H S O E. You say that all the letters are different here. So it actually implies the digits, and the naming is also different. So this also implies the naming of that elements. So first we'll see that how the naming will be done. Now this is actually applied for atomic number more than 100. First we'll take that atomic number 101. Now you know that in case of 1, the naming will be un. In case of 0, it will be nil. So first one, for the first one, it will come un with first letter will be the capital. So un, after that 0 will come, so nil is there. After that again 1 will come, so un nil un. But whenever the element is given, the last term will be ium, I-U-M. So always it will be end with ium. So the naming will be un nil unium, and the symbol will be the first letter of that digits. So first letter 101 is there. So first U is there, that will be the capital U. Second is 0. So for that 0, nil is there. So N is come here. And after that 1 is there, again U is coming. So U N U, that is symbol of that element. We are taking 102. That will be un nil B. Un for 1, nil for 0, and B for by for 2. So un nil bium. So symbol will be UNB. So un nil bium, the naming of this 102 atomic number 102 element. Similarly 103 un nil trium, and the symbol will be UNT. You can take any elements. 108 un nil octium, UNO. For 109 un nil enium, because 1 for U, un for 1, 0 for nil for 0 and n for 9. So un nil n and last is nium. So ium is there, so symbol will be une. So in this way you can name any elements more than 100. So this will become in the short questions like 1 marks questions. Write down the IPAC naming of elements like 104, 107 like that. Now the question is, what would be the IUPAC name and the symbol for atomic number 120? These questions will come like that. From the table, the root for 1, 2 and 0 are un, b and nil. Respectively are UBN and the name will be un by nilium. The symbol will be UBN, name is un by nilium. Clear? So you have to write down the first the name and then you have to write down the symbol, you will get full marks. If you just write down the name only, you will get half marks. And if you just full write down the name and symbol, you will get 1 marks. So today we'll complete this up to this IPAC nomenclature. Next week we'll do the SPDF blocks as well as the relation between the electronic configuration and the periodic table. We'll find out the position of the elements in the period table using the group, period and blocks. So this will do in the next class, the next lesson plan, and study this presentation whatever I've given. I'll show you in the PDF files. Study the PDF files and you have to write down all these things in classwork notebook copy. That's for it today. Thank you.